Okay, so at any rate, continuing with this little story of input-output, what have we done so far? We've used the MLAB read function to read data from a file. Pretty straightforward. Of course, when you get the data, you have to do something with it. You have to sort it or delete some of it or organize it. That's not the subject of today's story, although we've done a bunch of data manipulation here, just in printing things out, right? But our main point is that you can read a file, and indeed you can. You can also print a file to make an ASCII file for whatever purpose you want to, of course. Okay, well, let's continue this little story just a little bit more. Let's say Q0, well, I'm going to say Q0 is equal to the sort of the matrix Q0.
And what does the sort command do?
Well, let's find out.
Okay.
Bang. And then let's say Q0 row 1 colon 9. It sorts the numbers in our file in ascending order. This is the smallest number in Q0, 9.132 times 10 to the minus 3. So 0.009132 something. And this just goes on. The largest number in our file is going to be what? Remember, we read this from our file, which we made by generating random numbers between 0 and 1 with row numbers on them.
So it'll be 1.
No, the largest number will be 100 because remember we had that 100 by 1 and so on. So let's look at Q0 row parenthesis. We know that this is 202 numbers, I believe. So we'll just say 194 through the number of rows of Q0, which is just 202, right? And there's the last numbers in our list of sorted numbers, and we have two 100s. Why is that?
Is it repeating?
Because remember, our file said 100 by 1 matrix, that's 100, number 100, and then the row numbers went from 1 to 100. There's 100 at the front of the file, 100 at the back of the file, and when we sort them, they all come together. And there are 200s in the list of numbers in that file. Amazing. Computers do exactly what they're told to do. Okay, so we've just sorted those numbers, and now what we're going to do is compute the cumulative distribution function of these numbers. What is the cumulative distribution function? Well, it is a graph that says, it starts out with the smallest number, and it says there's one number that's, or whatever number of those smallest numbers there are, that's that number which is less than is the wrong, it's easier for me to draw it and then explain it. So that's what I will do. I will actually draw a picture of the CDF function on the data Q0, which is sorted, and I will view that picture. And here's the cumulative distribution function in this case. And what this says is that none of our numbers are less than 0. See, that's 0, 0. And then about 0.5 of our numbers are less than a very small number.
What is this axis here? Percentage?
No, this is, yes, exactly. Okay. This is the percentage. So this is 0.5 of our numbers, half of our numbers are less than something in here. In fact, less than 1. Remember, because what was our data? It was row numbers 1 through 100 and random numbers between 0 and 1. Well, half the numbers are less than 1. All the other numbers are bigger than 1 or equal to 1, right? So half the numbers are less than 1, and here they are in this straight line going up to 1/2. Why is this pushed over so far? Because this scale goes way out to 100. Okay, half the numbers are less than 1, and in fact, 1/4 of the numbers are less than 0.25 if you can go along there and just read at that point where this is rising up. If I zoom in there, this will just be a straight line like that.
Okay.
Okay. Then the next number in our graph is that a couple of our numbers, well, I said not a couple, we had two 100s, but what it boils down to is 100% of our numbers are less than or equal to 100. So that goes up to 1. All of our numbers are less than 100.
Mm-hmm.
Okay. Now, there is nothing in here except those row numbers, right? So what it boils down to is that going up, take this 60 right here. Okay, 80% of our numbers are less than 60. In fact, half of them are less than 1, and the other little fraction makes it 80%.
Mm-hmm.
Right there. So
Okay.
0.3% are between 1 and 60. So this is the cumulative distribution function of this data. And we might, if we were studying real data and had an interest in it, we might fit a distribution function model to some cumulative distribution function data that we compute with the CDF function down here, and estimate a distribution function for data. This is often an interesting thing to be done. Okay, so now I'm going to hit return, and I'm back here. And I really don't need to see this picture anymore, so I'm just going to say delete W, the picture that I have there. And I'm also going to say unview, so I don't even see that black nothing window. Okay, and now let us continue with our story about input-output.